Solar-powered flight. From a desert test to around the world. What happens if you cover an airplane with solar cells and ask the sun to provide the fuel? In 1974, engineer Robert Boucher's unmanned Sunrise 1 demonstrated that the idea could actually work. On November 4th, it flew over Bicycle Lake at Fort Irwin, California. Solar-powered aviation had begun. The next challenge was obvious: put a person aboard. In 1979, Larry Morrow flew the Solar Riser in California. Its solar cells charged batteries that powered the aircraft, a significant achievement, but not yet continuous flight directly from sunlight. Then Paul MacCready, whose team had already revolutionized human-powered flight, entered the story. In 1981, pilot Stephen Pitychek flew MacCready's Solar Challenger about 163 miles from France to England. Unlike Solar Riser, it didn't need batteries to store energy for propulsion. Thousands of solar cells supplied electricity directly to its motors. Solar airplanes could now carry people and actually go somewhere. But unmanned aircraft offered another possibility. Without a pilot, cockpit, or life support requirements, engineers could build extraordinarily light aircraft designed to climb far above ordinary airplanes. On August 13, 2001, NASA and AeroVironment's remotely piloted Helios reached 96,863 feet, more than 18 miles above Earth. NASA was exploring the idea of solar aircraft functioning almost like atmospheric satellites, remaining high above conventional air traffic for communications, scientific observations, and environmental monitoring. For piloted aircraft, however, sunlight presented an unavoidable problem: night. The solution was to collect more energy during daylight than the airplane immediately needed and store the excess in batteries. On July 7, 2010, André Borschberg took off in Switzerland aboard Solar Impulse 1. He climbed and charged the batteries during daylight, then flew through the night on stored energy. When daylight returned, the sun began powering the airplane again. The flight lasted about 26 hours. That changed the question from can a solar airplane survive the night to how many nights can it survive? Solar Impulse 2 provided the answer. On June 28, 2015, Borschberg departed Nagoya, Japan, for Hawaii. He remained alone in the cockpit for 117 hours and 52 minutes, nearly 5 days and 5 nights, while the aircraft repeatedly charged by day and consumed stored energy by night. Each sunrise effectively refueled the airplane while it was flying. But Solar Impulse 2 wasn't finished. Bertrand Piccard and André Borschberg alternated flying its single-seat cockpit on a journey that had begun in Abu Dhabi in March 2015. On July 26, 2016, Solar Impulse 2 returned to Abu Dhabi. After 17 flight legs, more than 26,000 miles and over 555 hours in the air, it had completed the first circumnavigation of Earth by a solar-powered airplane without using fuel. In just 42 years, solar-powered aviation had progressed from a small unmanned experimental aircraft flying over a California desert to a piloted aircraft traveling around the planet. And unmanned solar aviation points toward another possibility: aircraft that don't merely fly for hours or days, but potentially remain in the stratosphere for weeks or months, serving as extremely low-altitude alternatives to satellites. NASA's Helios program was already investigating this concept: the eternal airplane. Solar-powered airplanes aren't about replacing jetliners tomorrow. They're demonstrations of what becomes possible when engineers stop asking how much fuel an airplane can carry and start asking how little energy an airplane actually needs.